This video is going to be talking about the chain rule for derivatives, and it's pretty much used every time you take the derivative, but most prominently when you're taking the composition of a function. So by composition of functions, I mean f of g of x. And so if we were to take the derivative of that, then it would equal the derivative of f with g inside times the derivative of g of x. And so in an example, say we have sine of x squared plus x. We can let u, a variable, equal the inside, which is x squared plus x. And so we can rewrite this sine of u, because u equals that. And to take the derivative, we would just take the derivative of sine, which is cosine, and then we'd let u stay inside, times the derivative of u. So we can go over here and take the derivative of u. So that'd be 2x, and this would be 1. And then we can go back, cosine, plug u back in, which is x squared plus x. And then we can multiply it times the derivative of u, which was 2x plus 1. And then that's our answer. Now I'll go into another example. Say we have this equation. Now, in the past videos, I've shown you how to take the derivative of something like that, but obviously it's a composition of functions, so we would have to take the derivative of the inside as well, and that's different from just x squared. We can let u equal 3x squared plus 1, and then we can rewrite this as u squared. So the derivative of this will be 2u times u prime, or the derivative of u. So we can go back up here, take the derivative of u. So this would be 3 times 2x, and that's 0. So this will be 6x. So 2, and then plug u back in, so 3x squared plus 1 times 6x. And then simplify that equation. So 12x times 3x squared plus 1. And then this will be 36x cubed plus 12x. And that's the derivative. So the chain rule is used every single time we take the derivative. It just may not be used because of redundancy. So if we were to take the derivative of this and use the chain rule, then we would say this would be 2x times the derivative of x. Well, the derivative of x is just 1, so we're just multiplying by 1. It's the same if we were to take the derivative of 2x cubed. Then the derivative of that would be, well, that'd be 6x squared times the derivative of x. And that's still just multiplying by 1. So every time we take the derivative, we're always using the chain rule. It's just redundant when we don't have anything inside of x, because we would just be multiplying it by 1. Now if we were to take this and say, well, let's put x squared plus 1 cubed, well, then it would change. So now we can take the derivative of this. This will just be, well, let's let u equal x squared plus 1. So this will be 2 times 3, so the derivative, so let's just rewrite that as 6 u squared times the derivative of u. The derivative of u will be 2x plus 0, and so 6, rewrite this, x squared plus 1 squared times 2x, and that's a lot different than multiplying by 1 because we actually have something inside of our function. So this will be 12x, x squared plus 1 squared, and that is our answer. Now I'll go into one last example, and you can pause the video and try it on your own if you'd like. So this is it, and now I'll let you pause the video if you want, and I'll go in and explain it. So let's rewrite this as 2, let u equal 7x minus 2. That's the inside. So 2u cubed. Now the derivative of that will be 2 times 3, so let's just rewrite that as 6 again. 6u squared times the derivative of u. And that's our chain rule. Take the derivative of u, that's just 7. So rewrite this again, 7x minus 2 squared times 7. That'll be 42, 7x minus 2 squared. And that's the derivative. So I hope you understand that the chain rule is always used in derivatives, and it just might not be used every time. So thank you for watching, and I hope this helped.